So the next super exciting concept in databases is called as entity relationship models and entity relationship diagrams, right? So in short, they're often referred to as ER models, right? E and R stand for entity relationship, right? There are also something called as ER diagrams, and this is how an ER diagram typically looks like, right? So if you go to Wikipedia and if you see the article for ER diagrams, this is one of the diagrams that you will encounter. Again, you may not understand what this diagram is right away, but slowly and steadily by the end of this chapter, you will understand how to interpret this. Okay. So I just wanted to give you a big picture of what we will arrive at by the end of this chapter. But before we even go there, what is this? What is the whole purpose? What is the whole purpose of these ER diagrams, and what is the whole purpose of coming up with this whole ER model for a database? The purpose is very simple, right? So in a nutshell, the purpose of ER diagrams is to get a high level picture. The objective here is to get a high level picture of all the data that you want to store. High level picture of the database itself. High level picture of the database itself. Everything that you want to store in the database, right? All of the constraints. See, what is it? What does a database contain? A database contains multiple tables. Tables contains rows and columns. There are also keys, right? There are also integrity constraints, right? There are also integrity constraints, right? So we have seen some of these in the previous chapter, right? So at the end of the day, if I want to obtain a high level picture, for example, we started off with the task of designing a whole data storage system for Amazon. Now, in the very first video, when we gave an applied overview, we started saying that first we want to go to various teams, right? We want to talk to various teams that generate data and that use this data and come up with a cohesive understanding of the whole system. And literally what an ER diagram gives you is a high level picture. It is literally a diagram. See, look at this diagram. So this is an example from Wikipedia, as I just mentioned a while ago, right? So by just looking at a single diagram, sometimes this diagram can be massive, but by just looking at a single diagram like this, I can understand everything about what data is being stored in my database. I can understand a lot of things about keys, about constraints, about tables that I should have. All of that can be understood from a single picture, right? So this single picture gives you a high level overview of everything that's happening or everything that you want to capture in the database, right? So this gives you a logical view if you want to think about it. Okay, so that's the purpose of an ER model. Now throughout this chapter, we'll learn how to draw ER diagrams. We'll learn lots of details, right? Step by step. First and foremost, okay. So in the word ER here, if you notice in the word ER, there is entity and relationship. First, we have to understand what are entities and what are relationships, right? So let's start with that simple task. What are entities here? See, there is a textbook definition of what an entity is, but let's also understand it from a very practical viewpoint, right? An entity can be any object. Any object. First, let me give you sort of like a textbook definition, but I'll give you lots of examples, right? So an object that can be uniquely identified. An object that can be uniquely identified. Okay, so an object that can be uniquely identified is what an entity is. So for example, in our Amazon data set, right, or in our retail e-commerce data set, there are a bunch of very interesting entities if you think about it. So let's look at some examples here. A customer is an entity, right? A customer is an entity if you think about it, right? Because a customer is a physical object. Again, an entity can be a physical or a logical construct, doesn't matter. Similarly, if you think about a product, right? A product is also an entity. So one logical way of thinking about entities are nothing but nouns in English, right? If you're comfortable with nouns and verbs in English, right? Entities can be thought of as nouns, right? You can have a customer, you can have a product and things like that. And typically entities are represented in your ER diagram. Look at this. In your ER diagram, entities are typically represented. Again, if you notice, there are lots of shapes here in this ER diagram. There are rectangles. There are ellipses here. There are some special type of diamonds here. Okay, let's call them diamonds or rhombus, right? Oh, you also see something which has these are two rectangles, one rectangle and another rectangle, right? There are lots of these things. There are also something like M and N here. So there are lots of details that we will learn step by step, right? The first thing is an entity. Typically, we represented an entity in a simple rectangular box, right? So in the ER diagram, we represented the entity using a simple rectangle. So I can create an entity called a customer like this. I can also create an entity called a product like this, right? An entity is typically represented using a rectangle, typically, right? Okay, so let's go step by step. Okay, let's go step by step and understand how entities are related to tables and things like that. Again, while we are learning everything about ER diagrams, I'll also connect this concept of ER diagrams to tables, keys, and constraints, because that's something that we've already seen earlier, right? So let's go step by step. Okay, so this is what an entity is. What are attributes now, right? You can think of attributes very, very logically. You can think of attributes as properties. You can think of attributes as properties or features, right? Or features of an entity, So here, if you think about it, for example, a customer, see, look at this. An attribute is typically represented using an ellipse. Okay, an attribute is represented using an ellipse. Now, for example, you have this customer. Again, attributes in this context are associated with entities. Again, property attributes, you can have attributes for entities, or you can also have attributes for relationships. Again, we'll see what a relationship is in a little while, but just hold on that thought for a while, because first we'll learn about attributes for an entity. For example, here I have customer as an entity, and given this customer, what all features or what all attributes can I have for a customer? I can have a customer ID, I can have a customer name, I can have a customer address, I can have a customer zip code. All these are attributes corresponding to a customer. Similarly, if you take a product, right? You could have product ID, you could have product name, you could have product price, product type. All these are attributes of a product, right? I hope you're able to understand this, right? So if you think logically, we have already used this word attribute earlier in one of the previous videos, right? We have used this word attribute, right, to refer to columns in a database, if you recall, right? So imagine if I have this customer, if I were to store this information, I can actually store this information in a table, right? I can actually store this information in a table, right? I could have a customer table. Look at this. Customer is an entity here who has all of these attributes. So if you think logically, again, I will try to connect everything to tables. I'll try to connect everything to keys and things like that, right? Because we have seen at the end of the day, all of modern relational databases are worried about tables at the very core, right? So that's why we'll connect everything that we're learning in ER diagrams to tables also. For example, imagine I have this entity called customer with these attributes. I can actually store this. like this. I can have a CID column, customer ID, customer name, right? Customer address, right? Customer address. Similarly, I can have customer zip code, right? If you think about it logically, again, I'm trying to map this concept from a diagram to a table, right? These attributes of an entity can be thought of as column names. Remember, when we learned about tables, we use the word attributes and columns interchangeably, right? So this is one way to understand this concept and connect these concepts. Now imagine if I have a customer table. What does each row here represent? Each row represents an entity. Each row represents a customer, right? Because a customer has a customer ID, customer name, customer address, and a zip code. So you can think of, again, from this table's perspective, you can think of these columns as attributes, and you can think of these rows as entities, right? Similarly, I can have a product table. Similarly, just like in the case of customers, I can have a product table, which has columns like product ID, product name, product price, etc. Right? Now, if you think about this, these are attributes and these are also column names in this table, and each row in this table corresponds to one product, right, or one entity here. So if you want to think about it, if you want to think about the mapping from tables to ER diagrams, this is one very basic way of thinking about it. Again, there are lots of complexities that will kick in as we learn more and more concepts. This is one of the simplest ways to think about it. And that's why this word attribute, which we've used to represent columns in tables, is also the same term that we are using here. Okay, so that's one thing. The second important thing, there is a special type of attributes called as key attributes. There is a special type of attribute called as a key attribute. We know what a key is. A key uniquely determines each row in my table, right? So in this case, my customer ID is a key. My key attribute is often represented with an ellipse, and it is underlined. So when something is underlined, like for example, I underline CID here. Similarly, I underline PID here. The moment I underline this, I immediately understand that CID is a key. Similarly, PID is a key for this entity called product. So this product has these attributes. Amongst all these attributes, PID is the key attribute. Similarly, CID here is the key attribute. So all key attributes are diagrammatically represented in ER diagrams using an underline below the name of the attribute itself. Very simple concept. Now there is another very interesting example here. So there is a concept called, again, we are looking at various types of attributes. We understood what an attribute is. Now we are looking at various types of attributes. Key attribute being what the name suggests. It's a key. We have seen what keys are in one of the previous videos already, right? So now let's move on, right? So now there is another very interesting concept called as multi-valued attributes. Okay, for example, take the customer here, right? Take a customer. For a customer entity, customer can have phone number, right? A phone number is an attribute of the customer, but a customer can have multiple phone numbers. Look at this, a customer can have multiple phone numbers. Similarly, there is also an attribute for the customer like, let's say, credit cards, right? A customer can make purchases using like credit card, right? And a customer can have multiple credit cards. Now, how do you represent that information? Remember, a customer has just one ID, he has exactly one name, he has exactly one address, and he has exactly one zip code. But a customer can have multiple phone numbers because he may be having one office phone or one work phone and one personal phone. He may have multiple credit cards that he is planning to use to make purchases. So multi-valued attributes are typically represented using two circles like this, right? Like two ellipses or circles. Okay. So for example, in this case, if I just draw one more circle here, these are basically two circles like this or two ellipses. By looking at this diagram, I know that for this customer, there can be multiple phone numbers. For this customer, there can be multiple credit cards. Very simple examples. These are called as multi-valued attributes because each of these attributes can take, okay, let me not use the underline here because underline basically implies that it's a key. Okay, so I don't want to use the underlining here. So this is a multi-valued attribute, which basically means that multiple values will be present for a single customer. So given a customer, you can have multiple phone numbers and multiple credit cards, right? Again, think about what can be there for a product. What is a multi-valued attribute for a product? Think about it. Just pause this video for a second and think about it logically. For example, product type. Look at this, product type, right? Product type can be a multi-valued attribute because a product, for example, take some apparel item, right? An apparel item can fall in different categories or types. It can be a cotton fabric, right? It can be some special pattern, right? So type can be thought of. Again, it depends on how we design the database and what we mean by type itself. But if a product can belong to multiple types, right? And then given a product, it can belong to multiple types. Or in other words, given a product, it can have multiple types associated with the product. Okay, so this is one way. Again, this is not the only way. This is one way of understanding multi-valued attributes. Now, similarly, there is another very interesting concept called as derived attributes. What are derived attributes here? So for example, let's take an example, right? Imagine I have a customer. I have my customer ID, which is a key, zip, name, address. Imagine I have an other attribute called date of birth of the customer. because Amazon has some legal restrictions that they do not want to sell some items to people who are, let's say, below 18 years. Okay, they don't want to sell, or they may not want to sell some products to kids who are less than 10 years old or 15 years old, right? So it has to do that check. So Amazon might already have the information about date of birth of customers. So date of birth is readily available. For a given customer, there is only one date of birth, right? Now, from this, if I want to obtain the information about age, if I want to obtain the age information about a customer, remember, age is not readily present here, but I can derive age, right? I can derive age. So derived attributes are typically represented using dotted lines, right? So it's typically represented using dotted lines. So age is not readily available, but by using the date of birth, okay, let me not underline it, I'm sorry. So by using the date of birth and the current date, I can derive the age, right? So age itself may not be literally stored in any table, but if I have date of birth information, I can derive age, right? And derived attributes are typically represented using dotted ellipses. Similarly, imagine, very similar example, given a product, suppose if I have date of manufacturing, right? Imagine if I have date of manufacturing of this product, then I can have a derived attribute. I can have a derived attribute, which I can call it as the age of the product, or how old this product is, right? If somebody tells me the date of manufacturing of this product, I can say whether this product is 6 months old, 3 months old, or 1 year old, right? So here age of the product also is a derived attribute, because for derived attributes, I don't have to actually physically store them. I can derive them as using the current date and something like date of birth or date of manufacturing, right? This is again another type of attributes. Very simple examples here. Oh, next comes a very interesting thing called as compound attributes. Very interesting concept. Now, a compound attribute, let me give you an example here. Let's take name itself, right? Customer name. Customer name itself can have multiple parts. Customer name, this attribute itself may consist of other attributes. For example, this is customer's first name, right? Customer's middle name, right? In many parts of the world, many customers have first name, middle name, and last name, right? So if you think about it logically, this customer name is a compound attribute, right? Because it consists of other attributes which can be grouped together to arrive at the name. Similarly, address itself can be thought of as a compound attribute, right? For example, address can have, let's say, city, right? Address can have landmark, right? Landmark. Address can have things like road number or building number, right? So it could have all of these pieces. It could have building number, right? So all of these constitute an address, right? So in this case, your customer name and customer address are compound attributes. Very simple concept here. Now, so we've seen a few types of attributes. Again, we'll learn a lot more details. Again, I'm just giving an overview here of some very basic concepts of keys and attributes. We'll learn many more concepts through the rest of this chapter, right? So the next concept is called relationships. Again, this is just an intro. Please understand that. Relationships are very interesting. Okay. So for example, I have an entity called a customer. I have an entity called a product. Now these two are related through something called as purchasing or buying. Now look at this. If you look at this, again, a relationship is often represented in a diamond or a rhombus like this, right? It's represented in a diamond shaped thing, right? Now so buys is a relationship here. If you think about it, buys is a relationship. And what does this mean? A customer buys a product. This is how you understand this. Customers can buy products, right? And this relationship requires both without a customer, you can't have a purchase, right? Without a product, you can't have a purchase. You need both here, right? So you can think of buying as a relationship between the customer entity and the product entity, right? So relationship can be thought of as actually relationships between multiple entities. You can think of them as ways to connect multiple entities. In this case, we just have two entities, but you could have more than two entities also, participating in the relation. Now, if you think about it, okay, let's go into some more detail here, right? I'll give you some high-level overviews, but we'll dig into each of these topics as we progress. Now, a very important aspect here is, okay, a customer buys a product, but when he buys a product, okay, there are a couple of things that will happen. When a customer buys a product, there is a timestamp associated with that purchase, right? There is a timestamp associated with that purchase. Is time now an attribute of customer, product, or buys? Look at this. This attribute time at which the customer purchased a product, right, is actually an attribute of the relationship itself. Time is not an attribute of the customer because for us to have the time, you need to have both a customer and a product, and this customer actually purchasing this product at so and so time. Similarly, you could also have number, right? This is the number of products. Okay. For example, if I'm a customer, let's assume I'm buying a toothbrush, right? If I'm ordering 5 toothbrushes, right? That's the count or the number of items or products or number of items of a given product that I'm purchasing. So given a single purchase or a single buying, right? It has 2 attributes. So just like entities having attributes, it's very important to realize that relationships also can have attributes. And if you think about it, this relationship is called as M to N relationship. Okay, again, we'll learn about M to N relationships little later in lot more detail later. But if you think about it, again, this is called as M to N relationship. I'll explain you what that means. It's a very simple concept. Okay, so what that means is a customer, look at this, take one customer here. A customer can purchase N products. A customer can buy N products. A product can be purchased by M customers. Okay, this is multiple. So a customer can purchase multiple products. A product can be purchased by multiple customers. Right? Again, we'll see something called as 1 to N relationships, N to 1 relationships, all of this little later. Right? There's also something called as 1 to 1 relationships. We will see that we'll study them in a lot more detail later. But since we are anyway at this, I wanted to give this. See, because a single customer can purchase N products, right? That's why this is 1 to N, and a single product can be purchased by M customers. So this relationship is called M to N relationship, or it's also sometimes referred to as many to many relationship. Okay, this is also sometimes referred to as many to many relationship. Because one customer can purchase many products and one product can be purchased by many customers. That's why you have the many to many. Again, we'll see 1 to many, many to 1, 1 to 1, all of that little later. Just wanted to bring this up. Now, okay, so effectively a relationship is a way to connect multiple entities. In this case, we are connecting 2 entities. Now, if you want to think about it from a set theoretic perspective, okay, see all of databases can be understood from the concept of sets and relations. Okay, imagine I have a set of customers here and I have a set of products, right? A customer can purchase this product, right? A customer can purchase multiple products. A product can be purchased by multiple customers. Look at this. See, we have seen these types of diagrams, right? We have seen these types of diagrams when we learned about sets, relations, and functions in discrete mathematics. Again, you might have encountered these types of diagrams even in your 10th and 11th class when you learned about sets, relations, and functions. Right? So whatever we are representing in ER diagrams, whatever concepts we are representing in ER diagrams can also be represented using set theoretic notation also. For example, in this case, your customer, each dot here represents a customer. Of course, each dot will have a customer ID, name, address, and zip code, right? But if you think of the customers as this set, if you think of products as this set, what is this relationship buys? Again, buys has a timestamp associated with it, and buys has a count or a number associated with it, right? And this is a M to N relationship or a many to many relationship, right? Now, if you think about it, a customer can purchase multiple products, which I can represent using these arrows. So if this is a many to many relationship, again, in relationships, if you recall, even in discrete mathematics, we studied this. There is something called as many to many relationships. There is something called as one-to-many relationships and many-to-one relationships, one-to-one relationships. The same concepts, it's the same concepts that we will encounter in relationships in databases also. So the concept of relationships in databases and in discrete mathematics is one and the same. That's the beauty of mathematics, right? Once you know mathematics very well, everything becomes applied mathematics, right? I can literally go through whole of databases from a purely mathematical standpoint. Anyway, we will study that. We'll study something called as relational algebra a while later in one of the future chapters, where we will look at whole of databases, including SQL queries, right? We'll see everything from a set theoretic or a mathematical viewpoint. But I just wanted to shed this light to help you think on how this diagram also can be translated into a set theoretic diagram, right? There is one more view here, which is what is a table view of this? Again, we have understood what a relationship is. We have seen how a relationship is connected to concepts in sets. Now let's look at relationships from a table's perspective. Okay, suppose if I want to represent this information in a table, okay, I'll have one table here. I'll have one table here corresponding to customers, right, with CID as the key, right? So this is my customer table, right? This is my customer table. Okay, so let me write it here. This is my customer table. Very good. I'll have a table corresponding to my products. Very simple, right? I'll have a table here for my products, and this will have things like product ID, right? Product ID is a key here, all of these things. So this is my product table. This is my product table. Now I have a relationship here. Now in this case, again, we'll see various types of relationships and whether we need the third table or not, right? In this case, one way of thinking about it is to create a third table here, called the BICE table, right? Is to create the BICE table. And what all should we have in the BICE table? Look at this. What all should I have in this BICE table, right? So if you think about it logically, I should obviously have the count, the number here. I should have the number. I should also have the time at which this purchase happened, obviously, because these two are attributes of this relationship. They must be there. What else should be here? Look at this. This BICE table, look at very, very important concept here. This BICE table itself is relating a customer to a product, which means I should have the customer ID of the customer who bought and the product ID of the product which was bought. Now, if you think about it, this CID is a foreign key. This is a foreign key. This PID here is also a foreign key to this, right? This CID is a foreign key to the customer table. This PID is a foreign key to this table, to the PID in the product table. And this itself is your BICE table. And what all things do you have in the BICE table? You have the key. This key will be present here. This key will be present here. The primary key of the customer table, the primary key of the product table, and these two keys will be foreign keys as far as the BICE table is concerned. Again, remember that this is our BICE table, right? And of course, the attributes corresponding to the BICE relationship itself, like time and number, will also be here. Of course, I can also have one more attribute to the BICE. I can also create the purchase ID, right? I can also create transaction ID. Okay, I can also call something called as transaction ID, right? I can also add the transaction ID here. So let's call it TID. And TID itself could be a primary key for each purchase, right? I could have a TID also, right? So what happens here is when I'm trying to translate a relationship into a table, I will have all the attributes of the relationship and I will have the primary keys. I'll have the primary keys of the entities that are participating in this relationship here. This is one way of doing it. This is not the only way. We'll see a lot more cases here, right? We'll see many more examples like this. Again, translating from ER diagrams to tables is a very, very important task, because at the end of the day, your ER diagram is giving you a high level overview of what is happening, but you will have to translate your ER diagram to tables, because at the end of the day, your database, only your relational database, mostly is about tables, right? At the end of the day, everything has to be stored in tables. So given an ER diagram like this, it's a very, very important task to understand what all tables we should create, right? I hope you understood the story here. Okay. Now there is a very interesting concept called as participation. Okay. So let me explain again. This is all about relationships. Okay. Again, I'll give you some brief overview here. So there is something called as total participation and partial participation. Okay. So this participation is about, this is all about entities participating in a relationship. This is all about entities participating in a relationship. Okay, that's what we are talking about. Now, for example, let me take a simple example. Imagine, again, this is a very, very standard, nice example of total and partial participation. Very logical thing. So imagine I have employees in my company, employees at Amazon, let's say. Every employee, again, employee here is an entity because it's in a rectangular box. Every employee has an employee ID, which is a primary key because it's underlined. Employee has employee name. So this is an entity. There is also an other entity called a team. Okay, or a department or a team, right? This team has something called as a team ID. Okay, team ID is unique for each team. There is also a name associated with a team. Now, if you think about it, every team needs to have a manager, and the manager himself is an employee. If you think about it, just think about it logically, right? So every employee, look at this, every team, the way you have to think about it is every team. See, every employee need not be a manager. So this relationship is called as manager's relationship. So what this attribute says is that this employee is managing this team from this date. Okay, again, let me not underline it. Sorry. I have a bad habit of underlining it, and underlining has a special meaning in databases. Okay. So the way this relationship works is this employee is a manager of, or he manages this team from so and so date. Right? That's how this relationship is constructed. Okay. This from is basically a date from which this employee is managing this team. He's a manager for the team. Right? Now look at this. Every team needs to have a manager. Look at this. Very, very important concept. Every team needs to have a manager. Which means, think about this. Imagine this is a set of all employees. Okay. This is a set of all employees. This is a set of all teams. Right? For every team, and what is a relation? Relation is basically this mapping. Okay, this is what your manager's relationship is, right? So for every team, you need to have somebody who is managing it. Which means in this manager's relationship, this entity team participates totally or completely. Because again, this is what total participation means. Okay, total participation basically means, so total participation. Okay, the single diagram can explain both these concepts very easily. Total participation basically means for every team member, okay, every team member should participate in this relationship. Or in other words, every element of this set, every element of the team set should be mapped to, or should have a relation. This is called a pre-image actually in sets and relations, right? It should have a pre-image in the employee set. Okay, so everyone should have a manager, right? Hence, this team is said to be totally participating in this manager's relationship, and total participation is represented using two lines. Right? The moment you see two lines, what does this mean? It means for every team here, there is a relationship that is present here. But if you look at this, there will be some employees who are not managers, right? There will be some employees who don't manage any team. So if you look at it from, so we say that the team entity participates totally or completely in the manager's relation. But the employee entity does not participate totally or completely in the manager's relation. Because if you think about it, there are some employees here who do not manage any team, right? So employee is said to partially participate. Okay, is said to partially participate, okay, in this relationship, while team is said to totally participate in this relationship. And total participation is represented using two lines. The default is single line and the default is partial participation. Okay, and this is a set theoretic view of understanding it. For every team here, look at this. For every team here, there has to be a manager. Okay, there has to be a manager. because these lines represent the manager's relationship. But every employee here need not be managing a team. Hence, employees are the employee entity is only partially participating, because it's not totally participating, while the team's entity is totally participating in this relationship, right? Again, these total participations and partial participations are very, very important constraints. So you can think of them as integrity constraints. Okay, you can think of them as integrity constraints. And these are typically user-defined integrity constraints, because the user says that for every team, we need to have a manager. And given any employee, or every team needs to be managed by one employee, right? But it also says that every employee need not manage a team. And this is actually a business requirement, or this is a user-defined integrity constraint. So you can think of total and partial participations as a form of integrity constraint, as a form of user-defined integrity constraints, right? So I hope you got a good introduction to many of these topics, but please don't worry, we'll dive deep, we'll learn many more concepts about ER diagrams, and hopefully by the end of it, I hope you've already started understanding some of these diagrams, right? For example, look at this. Okay, now you know what, okay, again, there's some more pieces that we need to understand here. Okay, so you at least understand the M to N relationships now. You understand that this is a relationship, right? So some of the pieces, you understand that this is actually a primary key here. This is a primary key here. Hopefully by the end of this chapter, you'll be able to completely make sense of any such diagram. That's the hope here.